Here we have the cylinder from example 1 with the cone from example 2 taken out of it. And we're going to find the volume of this new shape. The shape created by taking the cone from example 2 out of the cylinder from example 1. Now, there's a couple ways that we can do this. And I'll just show you the first way, and in so doing, I'll be able to show you the second way as well. So the first way to think about doing this is to take the volume of the whole cylinder and subtract out the volume of the cone. So let's say, so we have the volume of the cylinder, right, and that's just the whole thing. And we're going to subtract out the volume of the cone. And you can think of that cone as being inside of this thing. I'm going to subtract it out. So let's see, the volume of the cylinder, we figured that out as the integral from 0 to 5 pi times 2 squared dx. And now the volume of the cone, integral from 0 to 5 pi times 0.3 x squared dx. Now we have a rule about integrals that we can, you may remember that the integral from a to b f of x minus g of x dx is the integral from a to b f of x dx minus meaning that we can split integrals over sums and differences. So here it's already split, so let's put it back together. So we're used to going in this direction with the equals, but we're going to go in this direction. Guess we'll put it all back together. 0, 5, pi times 2 squared minus pi 0.3 x squared dx. And now notice this pi here, right, it occurs in both of them. So using the distributive property, we can pull that pi out. So I'm just going to do that right here. And go like so. Now let's just pull that pi, pop that pi all the way out. So now we have pi 0 to 5, 2 squared minus 0.3 x squared dx. All right, so that's really the second way of doing this. The second way of doing this is just to realize that this volume of this new shape, the volume of the new shape, and this is the shape that's formed by rotating the area between y equals 2 and y equals 0.3x around the x-axis. So if we were to think of it as a two-dimensional area being turned into a three-dimensional shape, that two-dimensional area would be this part right here. And so now think about what that shape would look like, right? If you were to rotate this blue triangular shape around the x-axis 360 degrees. So we have pi integral from 0 to 5, 2 squared minus 0.3 x squared dx. And now what I want you to notice is that this is the outer radius. And this is the inner radius. So this outer radius is that whole distance, and we're taking away the inner radius squared. And that leaves us and if you think of these as, if you want to think of them as with the little discs, right, we can make a little disc there, and our discs would look something like this. Right, and that's this whole idea is we have the outer radius minus the inner radius. And I'm sure you've done problems in other classes, right, where you have a circle and then a little circle taken out of it. How did you get this radius here, the radius of the donut? You took the area of the entire hole and subtracted out the area of the so you found this whole area here, right? And then you subtracted out this little area there. And that's exactly what we're doing right here. That's exactly what we're doing right there. The area of the whole, take away the area of the inner piece. In any case, now we can go ahead and compute this thing. And let's see, what do we get? 51.05 cubic inches.